So next up here, we're just going to set our timing belt tension. There's a couple things we're going to move into here before we do that final assembly of the remaining components. We're going to set our tension. We're going to degree the camshaft. I thought about maybe doing that in a different, completely different video altogether, but we do have to do it on this engine anyways, so it might be a whole entire episode of its own, but we'll cover that. It has to be done before we put the valve covers on anyways, ideally before you put any of the front cover stuff on as well. So what we're going to do here first is we're just going to tension the timing belt. There is a couple ways to do this. The manual tells you to leave the tension loose, rotate it a couple of times, and then torque it down, and that should be your tension. It can be a little bit different if you're using a Kevlar belt. So you may want to be a little bit tighter, a little bit looser, depending on the material of your belt. If it's too tight, it'll make a lot of noise. If it's too loose, it'll slap against the cover. So for this consideration of this belt, it's a Tomei belt. It is Kevlar. So we're going to tension it kind of in the middle of what we'd expect for most belts. So I like to just tension get this side of the belt completely snug, and then kind of feel how much slack you have in this area here. Generally, the spring will apply all the tension you need, but we're just looking for, I guess, loose feeling here. You're not going to end up with an exact measurement. You're going to have to do this basically by feel. It is kind of an old design on how to tension the timing belt. But the way I like to describe it is you kind of get a backward and forward movement, just a little bit more than the thickness of the belt. So if there was 3 layers of belt here, you'd get 2 layers there, 2 layers there. So basically in and out, you can get a good tension there. Remember that you're just trying to hold the belt onto the gears. You don't need to force it to stay on. It's not like a serpentine belt where it needs constant tension because of grip. This one has teeth on it, so it does not require force to hold it on. It just needs to be, I guess, guided. Feels good. So once you feel that your tension is good, again, I like to apply a little bit of force to this side here and then give it a feel. Now, once you feel it's good, you can just tighten this down by hand quickly. We're going to spin it around a couple times. Okay, now once you spin it around a couple times, line up your timing marks on all 3 areas, and then we're going to check our tension. Now, usually, again, I like to check the tension with a bit of force on it, because this is going to be tight when the engine's running. This side will be the loose side. A little bit on the loose side, so we're going to go ahead, we're going to adjust it again. Now you can apply a little bit of pressure onto the belt just to get it into what you feel is the sweet spot. Again, you're going to want just a little bit of kind of a slap motion. And once you're holding that tension, tighten it down again. It might take a couple of tries. Again, you don't want to force the belt on there, you just want to support it. And still rotate it. Unlike this side's very tight. Again, because we're applying pressure to it, even if I release the pressure, this side's very tight. This side's loose. We're going to do the same thing again. Just want the belt to settle into the position that's going to be staying in. Because this is a manual adjustment, you don't want to have to do this twice. So you may as well just spin it around a couple times. Feels a lot better. Just a little bit of tension on the right hand, and then you can see that already looks a lot better as far as the tension we have. Again, we just kind of want, if there was 3 layers of belts here, we wanted to just offset about the thickness of the belt in both directions. We consider that tension. Again, this side's both tight. This is going to be the constant tension side. This is going to be the relaxed side, so you always check it on the left side when you're looking at the engine. So we've got that tension, we'll consider that good. Next up, we're going to torque down the ARP tensioner stud down to 43 foot-pounds, just like the factory specification. And then always check your tension again, because if you do tighten that down, it can move. A little bit of tension on the one side, feels good. Now again, I always recommend you put pressure on the right side, because the engine, when it's running, is going to always have more tension on this side. It does kind of come and go, but for the most part, under tension, you want this to still have a little bit of slack. But when it's not in, if you set the timing belt tension when it's relaxed, this side could feel tight, or if you set it to be loose in this position and then you go and put pressure here, it's going to be even more loose. So that's why I recommend doing it this way, a little bit of pressure. You can kind of feel it. This pretty much ends up with good results, limited noise, if any, and then you also end up with good long timing belt life. One thing to also note when you do set the timing belt tension and the engine does heat up, it does get taller, so it does tighten the belt down even more at operating temperature, and that's usually where you get that timing belt noise later on after the engine's been running for 20 minutes. Okay, so now that we have that tension there, we're going to paint pen our bolt now that we've torqued it, just like we've been doing. So if we walk away, we come back, we know we've done that. Now one more thing to mention, obviously, say you set it too loose and you happen to jump a tooth. It's a very rare occasion that that does happen, but if you do set this too loose, you're turning it and it does skip, you happen to not notice. You just want to verify your timing marks are all lined up again. The mechanical ones are going to be just the 3 dots that we talked about already. The belt will never come back to the same location. Well, it will eventually, but not after 1 or 2 rotations. Again, always check it at TDC with the cam dots facing outward, just like you would do on a standard timing belt. Now that we've got our timing belt tensioned, we're going to go ahead, we're going to move on to the cam degreeing. Again, the reason you degree the cams is to set them up in the position that the cam manufacturer intended them to start opening and to start closing. You can slap a camshaft into an engine, but it can be off a couple degrees as far as manufacturing is concerned. The center line has to be aligned with what the cam gear is actually aligned to against the crankshaft. So we're going to go ahead now, we're going to try and break down each step and show how that process is done, and then what it looks like afterwards. On some occasions you can actually have them be perfectly bang on 0 degrees, it's good to go. But usually 2 to 3 degrees adjustment is required. So we're going to go ahead now, we're going to put our crankshaft pulley on here that has a degree wheel on it, and then we're going to set our true TDC with a mechanical pointer that we have, which is just a steel wire, and then we'll move on to the next step. We've got our degree wheel on here. You can see this goes 0 to 360, just like a standard degree wheel would be used for. And then we're going to just put our homemade pointer on here. Okay, we're just going to set this up to 0 for now. This is just going to be a temporary setup. We'll have to adjust it when we find true TDC. It's just a steel wire. Coat hanger works as well. Bolted the head. The reason we use a more accurate pointer than the rear cover is because the rear cover adds kind of a bit of a perspective angle to where the pointer actually is, and you can I guess misread where it actually sits. So we're going to go ahead, set that up like that. A couple things you'll need. You'll need a pretty long dial indicator. A couple reasons you need the dial indicator. We're going to use this to find true TDC and then set our piston stop. We're going to use this to measure the cam lifter location. So you do kind of have to have a bit of a bend on the end to get it around the cam on the 26 specifically. This one is a bit of a in-house construction. It's been extended so that we can measure deep down into a hole. So that's one tool you'll need. You can modify your own dial indicator to work for a one-time use because degreeing a cam is not an everyday thing. And then next up we need a piston stop. We've just gone ahead and created our own with the old spark plug, a long M8 bolt and M8 nut. And then last, you'll need a dial indicator stand of some kind. This one has a magnet on it, so we can put on something steel and it will stick where it needs to be. Obviously you'll need the degree wheel that we already installed on the engine and a pointer of some kind. And then last but not least, you'll also need your cam card from the cam manufacturer. This has the specifications that the cams should be set to in order to, I guess, reflect the exact advertised specification of the camshaft. So we have that as well. You can either use the magnetic fixture, or you can use a fixture like this where you can pretty much clamp it on anything and then you can lock it down in the position that you want to leave it at. So we're going to use this one for this instance because we don't have anywhere steel to magnetize to. So we're going to be using this one instead. Okay, so first thing we're going to do, we're just going to set our pointer to exact before we install our piston stopper. So we're just going to use a dial indicator just to guarantee that we have placed the engine at true TDC. Now you got to pay attention to it where the needle will switch back. So it's sweeping one way, it stops and goes the other way. Right where it stops is going to be your TDC position. So it looks like we're just 1 thou off of where we zeroed it. with the pointer on here, so we're only a degree or two off. We're just going to adjust the pointer to sit directly above the TDC or the 0 mark on some gauges. So you can see just like that on here, we're at the 0 mark. We've completely zeroed top dead center. So that's good. Now we're going to install our piston stop. Okay, so for this next step, we're basically just going to do a mechanical verification of what we've already done with the dial indicator. The piston stop is basically just going to be used to confirm that we've gone all the way one way and then all the way the other way, and then we're going to do a little bit of math and guarantee that those two numbers equal 360 degrees. That way we know that we've got our pointer exactly where it needs to be as far as crankshaft location. Okay, so first thing we're going to do is just turn the crankshaft forward a few degrees. That way the piston stop can be installed without being jammed up. So we're going to go ahead first, we're going to install the lower half of the piston stop, which again is just a 5/8 spark plug from RB already. Make sure it's snug, doesn't need to be too snug. Okay, so now that you got your piston stop installed, or the bottom section of it, we're going to go ahead now. We're going to rotate our crank backwards about 50-60 degrees. Now I'd recommend going backwards just so the math makes sense. And then we're going to set our depth just a little bit higher than the 50 degrees we're at, so we're not going to actually touch the piston itself. So we're going to spin that down. Okay, now that we've got our stop depth set, we're going to spin the crankshaft back a few degrees until it stops. Okay, we've stopped. We're at 33 degrees. So now we've rotated backwards, we're at 33 degrees. We're going to record that number. We're going to take that number in order to find out if we're at true TDC. We're going to take that number 360, which is the total degrees. We're going to subtract what we've just recorded. So that's going to be 33 degrees. So 327, when we spin the crank backwards, we should get 327 if we've set our dial indicator, or sorry, if we've set our pointer in the right location. So we'll go ahead now, we'll spin it the other way. Perfect. Yeah, good. So we've spun it the other way now. We're at 327 degrees. So we know that our pointer is set at true TDC. And now that that correlation has been made, we can remove our piston stop and set our engine back to TDC. And then we're going to move on to the next step. Okay, so now that we've got our pointer set, make sure you don't budge this. If this moves, again, this is a relationship between cam and crank. So if you move that at all, you may as well not even touch the cams. We're creating and dialing the relationship in between the two, so we need that to be absolutely perfect. So if you bump it or anything like that, you got to go back, set it up again. So what we're going to do now, we've removed our piston stop. We're going to go ahead next now, and we're going to set up our tooling so that we can measure the cam lobes. We're going to start with the intake side, and then we'll move on to the next steps. We've set up our dial indicator. This is probably going to be the trickiest part. Like I said, we had to modify a dial indicator to kind of reach around the camshaft. If you're working on a pushrod engine or anything that doesn't have overhead buckets, it's a lot easier. So we kind of have to work around the camshaft in this situation. So what we've done here is we've set up a bracket to allow our magnetic mount to fit to the cylinder head. We tried it with the clamp, but it wasn't quite working, so we've kind of makeshifted something here quickly. We've gone ahead, we've kind of placed the dial indicator on top of the bucket. We have about a 0.6 of an inch of preload on the dial indicator, and it's touching the bucket. Keep in mind you have to keep it away from hitting the lobe when you do rotate the cam, otherwise it'll kind of skew your readings. So what we're going to do now is we're going to check our cam opening, or valve opening, valve closing, and where those degrees correlate relative to crankshaft location. So first thing we're going to do here is we're going to pick I guess a lift location on the dial indicator that we're going to reference on both opening and closing. So we're going to pick 40 thou. So that's going to be the 60 mark on the dial indicator here. So when we come down, we're going to go 10, 20, 30, 40, which is going to be 40 thou. We're going to go to the 60, we're going to record our degrees on the crankshaft, and then we're going to keep rotating. So once the gauge comes back around, we're going to record the same degree on the crankshaft at the 60 again, and then we're going to take those two numbers and do a little bit of math. So first things first, make sure you set it to 0. Done that. We're going to rotate it down. Now you can see it starts to open. And then we're going to stop at the 60. And we're going to record the degrees on the crankshaft. In this situation, we are at 231. So we're going to record that 231. And then we're going to continue rotating the cam, or the crank, in turn rotating the cam. See, it'll rotate all the way around. And then we'll reach peak lift. And then it begins to rotate the other way. Now you're going to want to pay attention when you get close to the 0.6 or 60 thou area here. You're going to want to pay attention to when it reaches the 60. Or you can just watch the cam lobe when it starts to come off the lifter. Pay attention to when we start to stop at that 60 again. So we're coming off now. It's going to be on this rotation. We're going to stop right when we get to the 60. Again, more or less, we're going to record our degrees here now. So we're at 1, 2, 3, 4 degrees. Okay, now a little bit of math with those two numbers that you just recorded. You're going to add them together and then divide them by 2. 231 plus the 4 degrees, 235, and then you're going to divide that number by 2, and that's 117.5 degrees. Our exhaust before top dead center center line is 114 degrees, so we are 3.5 degrees out from what the cam manufacturer recommends. In this case, it's Kelford. So what we're going to do is we're going to adjust our cam gear now to reflect what the card says it should be at, and then we will recheck it and make sure we're correct. 3.5 degrees of camshaft center alignment misalignment. So what we're going to do now is we're going to move the cam gear. We'll probably just do 4 degrees. We can try and do 3.5. But the Tomei cam gear has 2 degree marks for crank angle. So we're going to move those 4 degrees, and then we'll recheck it, see where we're at, and see if we have to go back or more. Okay, so now that we've adjusted the cam gear to 4 degrees, we're going to check again and see what kind of numbers we get. So we're going to rotate again to opening position. We're going to stop at the 60. Record our measurement. 228. And then we continue to rotate. As you come back, pay attention to where that closing mark is going to be. We're going to be at the 60 again, so right about now. Stop at the 60. And we are at 1 degree. Okay, so 228 plus the 1 degree, so 229 divided by 2, 114.5. So about a half degree from where we want to be. I'd say that's about as good as we're going to get. We'll do one more spin just to verify that what we've measured this first time is actually accurate, and we can repeat it, and then we'll move on to the intake side. 228. Again, don't need to record it, we already know what we have. Keep rotating. As we're coming back around, stop at the 60. 1 degree again, TDC, or 1 degree past TDC. Again, we're going to call that even. We already know that that math adds up to the 14.5 degrees. Again, you're going to be splitting hairs. You can try to get that half degree out of this cam, out of these cam marks. You'd be hard pressed. Again, we're as close as we're going to get without the little bit of margin of error that's going to be with all the equipment we have here. So we're going to move on now to the intake side. We'll rotate this back to TDC, and then we'll set up on the intake side. Okay, so we've got our dial indicator set up now on the intake side. With the Kelford cam, it's a little more tricky. The hex on the front of the cam is really, really big, so it makes it even harder to reach the lobe. So again, it's going to be a bit of a pain, but we can kind of get the measurement in here and check our degrees. So what we're going to do, same thing as before, 40 thou, which is going to be on the 60. It's going to decrease the number. So once we hit the 60, we're going to record our angle on the crankshaft. Okay, once we hit the 60, we're going to record our measurement on the crankshaft. And we have 55 to 657, 357 degrees. And then we keep rotating. And again, we're going to mark at the same point. Okay, as the valve starts to close, coming up on the 60, we're going to stop again. Okay, and we have 129 degrees. Okay, so for this calculation, a little bit different than the exhaust one. You're going to take your first number, which is the 357. You're going to take 360, subtract 357. That's going to give you 3 degrees, at least on this application. And then you're going to take your 129. So 360, subtract 129, 231. Okay, now we're going to take those two numbers and add them together. So 231 plus 3 equals 234. And we're going to divide the 234 by 2. That gives us 117. We've measured 117 degrees initially. So what we're going to do now is we're going to advance the cam the 7 degrees out that it is. Again, these marks are 2 degrees, so we're going to go 2, 4, 6, and 1. It's just going to be like half in the middle. And then we'll remeasure after we get that locked down in place. Once we've got it in position, we'll torque it down again. Okay, so we move the cam gear the 7 degrees out to adjust the center line. One thing I did notice with the higher lift camshaft, longer duration camshaft, is sometimes you have to choose a larger number reference point on the dial gauge. Otherwise, the numbers that you get don't make sense. I won't explain any more detail into that just because it'll get really confusing. It's past 360 degrees at some point. So what we're going to do is we're going to change our reference point. We're going to put it all the way down to the, what is this? 10, 20, 30, 40, 50, 60. We're going to put it all the way down to the 0.6 of an inch as our reference point, so we get past the 360 degrees, so the math actually makes sense when we go to calculate it. So what we're going to do again here is we're just going to rotate the cam. Our new reference point, which is going to be the 40 here on the bottom little right of the gauge on your side. Okay, we're at the 40. We're going to record our degrees. And they are 359. So 359 degrees. And then we're going to continue to rotate. Again to the opening point. You're going to want to pay attention when you come up on that 40 again. Stop. And we're going to record our degrees, which is 140. So we're going to do 360, subtract 359, which is going to give us 1 degree. And then we're going to go 360, subtract 140, which is going to give us 220. We're going to add those together, so 220 plus 1, obviously, and then divided by 2 gives us 210.5. Sorry, gives us 110.5. And our desired after top dead center angle center line is 110 degrees. So we are 0.5 degrees within spec. Again, so what we're going to do with that information now is we're going to just double check it again, make sure we land in the same spot as we did the first time. We've double verified and we've degreed our cam successfully, so we can move on to the rest of the assembly. Okay, so come around to the 40. Again, 359. $140. So we already know those are the same numbers we got before. We do the same math, end up in the 110.5, which is a half degree within range, which is an allowable margin of error for what we're doing here. Once you finish adjusting your cam gears, you can go ahead and you can torque them down. Torque spec is 78 foot-pounds, just like any M6 bolt would be. If you're tackling this job yourself, You're probably going to find out how annoying it can be, especially with the overhead buckets, trying to get around the camshaft. Setting up your timing pointer to be exactly on true TDC. There's a lot of reasons why this is painstaking. I can see why some people just bolt the cam gears on and leave them and don't actually adjust them. But this gives you the most efficient set of cam location. So when you go to tune the engine, you get the most out of the camshafts that you put in your engine. We're going to go ahead now and continue on the assembly of the rest of the items, and then hopefully get this thing buttoned up.